Hello fellow KSPers, this is Steve Lawyer, and let me introduce you to the Delta V calculator. This is a handy spreadsheet that I use when I'm flying my own ships, particularly when I'm flying stock, in order to precisely calculate how much delta V that they have and how long the burn time will be for any particular maneuver that I'm going to perform. If you've watched any of my other videos in which I talk about using my delta V calculator or my spreadsheet, this is what I'm using. So I've put this up with a link on Dropbox. There's a link for this video to where you can download it and use it for your own ships. Let me show you real quick what it does and how it works. As you can see, it allows for up to 50 stage rocket. Probably not going to be flying anything with that many stages. Just like in KSP, the lowest stage is the last stage to be used. In other words, you're progressively moving down, dropping higher stages and working your way down as you go. For every stage, you can have up to 3 different types of engines running with an unlimited number of that type of engine running, and it will calculate for you the delta V and the burn time. Now, this works completely with any traditional staging rocket or any asparagus staging rocket. So traditional staging would be where each stage burns till those tanks for that stage are exhausted. Those engines and those tanks drop off and the next stage lights up. Asparagus staging is, of course, where not only is the current stage's engines burning, but a later stage's, lower numbered stage's engines are also burning, and the fuel is down feeding so that as each stage falls off, the lower stages are left full to operate. This example rocket that I have on here has some of both, and an important thing to understand is if you are doing asparagus staging, you need to enter all of the engines that are running during a particular stage, including engines that are in a lower stage that are going to continue to run for that stage. So for example, here you can see stage 2 right here. I've got 6 engines that have a thrust of 50 kilonewtons per engine and an ISP of 390 that are going to fall away with that stage, but I also have the engines from stage 1 getting fuel from that stage, and you'll see then over here in engine 2 I have engine type 2, I have the exact same engine parameters entered that are going to continue to run after stage 2 has fallen off. This example rocket, just to show you both, then has traditional staging from 2 down to 1. In other words, from stage 1 down to 0. In other words, these engines on stage 0, this is obviously an LVN, are not running at the same time as stage 1 engines are. If they were, they would need to be entered here as well. So it gives you an idea. Basically, when you enter into this table, you need to enter the number of engines, their thrust in kilonewtons, and their ISP for every engine that's going to be running during the duration of that stage and drawing from the fuel for that stage. So let's talk about the fuel entries over here. For each stage, you put the maximum amount of fuel that's available to that stage only. In this case, for example, 2160 of fuel. If I fill my tanks are full, that's how much fuel is going to be available not only for these engines but for the engines that are being fed downstream until this stage departs. Obviously, in an asparagus circumstance, then these engines continue to run under the fuel that's associated with that stage. The actual fuel that you have on board, if you're not full up, then of course this is the amount of fuel that's currently available for that stage. Your mass, now your mass is your mass with full fuel, so it is not the mass of that stage. These numbers are the fuel for that stage alone. The mass is the total mass of the ship, including all prior stages and their fuel, for that stage with full fuel. Now, if you have a circumstance like here, where your actual fuel is less than your maximum fuel for that stage, then this spreadsheet automatically calculates what your current mass is because of you having less than full fuel. So it's important to understand that this is your mass with full fuel. If you don't know what that number is, but you know what this number is, don't type in the current mass here, because you can see this is a calculated, a derived number. But as you can see here, you can quickly convert any missing fuel by taking the difference between your max fuel and your actual fuel and dividing that number by 90 to get tonnage, and then you would add that onto your current mass to put in your mass, what your mass should be with full fuel. On that note, it's important to understand these fuel numbers that you're using are liquid fuel only. The spreadsheet assumes that you have available the corresponding amount, which is about 1.22 times your liquid fuel amount of oxidizer, and it already factors in for that oxidizer on a weight basis. So don't add liquid fuel to oxidizer when you're doing this. If you're not remembering any of this, or you just want to skip to the end, you don't want to watch this video, and you want to go ahead and download this and play with it, there is an instructions tab that explains how to use the spreadsheet pretty clearly. It doesn't cover everything I'm going to cover here. You get over to this third column, and you can see then you've got your delta V. This is the delta V that each stage has available till it runs its current fuel load to exhaustion. And then you got a total delta V column, which shows how much your total delta V is if you were to burn the entire ship to exhaustion. If you move further to the right on this spreadsheet so you can see additional columns, you can also see that you've got what the burn time would be at full throttle for that stage until that stage is exhausted, and what the total burn time of the rocket is until exhaustion. These last three columns over here, delta V needed, fuel needed, and stage time, are derived numbers that are really used for calculating burn time, but I'll show you what helpful information you can glean from them. So here, the key things, of course, is you got what your delta V is for any particular stage, how much delta V you can nurse out of this ship, and then, of course, you can click, not of course, then you can come here to the burn time tab, and here's a very valuable, probably the most valuable portion of this whole thing. You can determine how long a burn is going to take. So let's say I need to get 1,000 delta V out of this stage. I can put that number in out of this rocket in its current configuration, and this tells me that if I start with the vessel as laid out over here, in other words with that current amount of fuel, those engines operating, my burn time for 1,000 delta V is going to take 1 minute and 4 seconds. So now I know, well, I need to start that burn 52 seconds, half that amount, 52 seconds before the maneuver node, so that it burns equally before and after the maneuver node. Now, don't forget, this doesn't put in any margin for you. So if you're in a close-in orbit where you lose some of the efficiency of the maneuver, if you start the maneuver if the maneuver is other than instantaneous at the exact moment of the maneuver node, you need to factor something in for that. I normally will factor in somewhere between 10 and 15% of overage on a orbital maneuver, low planetary orbital maneuver, to allow for the fact that there's some built-in inefficiency of the engines running at any point other than precisely at the maneuver node. So what you can do, of course, in that kind of circumstance is come up here and say, let's multiply this times 1.15. That'll get me, so for that 1,000 delta V maneuver, I probably need to actually plan on expending 1150 delta V, which means my burn time is going to go up, you can see here, by some additional seconds, and now I can have that number. So let's go back to the vessel config page and see how that affects what we see here. Well, as you can see, for example, I wanted to do 1,000 delta V, and I've got only 828 delta V on this on the first stage that I'm going to be burning off of, stage 2, that I'm going to burn and then eject. So these columns, again, they're not real clear what they are up here, but you can see what this is saying is going to happen is that if I'm going to burn 1,000 delta V, after I've used up all of this 828 delta V, I'm going to need 321.9456 delta V from the next stage lower. That's what's going to be demanded of this next stage here out of this 4,172 total possible delta V for the next stage. All right, and then you can see for the fuel needed, the fuel needed is how much fuel from the current stage I'm going to need. So these numbers are a little bit deceptive in that what they mean is varies a little bit from the delta V needed is going to be for the subsequent stage, what's going to be needed for the next stage after me, whereas the fuel needed is what I'm going to demand from the current stage. In other words, here you can see I'm going to demand the full 1,200 of the actual fuel that's available in this stage, and then I'm going to burn 358 out of the 2,880 for the stage below it when I get to that stage, and I'm going to burn for the entire 52 seconds of available burn time on stage 2 before I eject it, and I'm going to have 22 seconds out of the possible total burn time of 179 seconds available on stage 1. So that gives you an idea of how to read this. Like I said, the most important thing on this is probably your burn time, being able to calculate burn times precisely, and also knowing what kind of delta V capability your rocket has, your total delta V and your delta V from each stage, so you can sort of figure out what's going to happen. So you can go ahead and download this and use it. One more thing to know is, well, you might ask, well, what if I've got a stage that's not a traditional staging rocket? I got a rocket that doesn't do asparagus or traditional staging. Can I still use your spreadsheet? The short answer is yes. So long as you're not going to be throwing off a stage during that burn. And a very simple way to use it in that kind of circumstance, imagine, if you will, that I've got a rocket. I'll just come down here to a blank line. I've got a rocket where I just want to know, for a certain current amount of mass, how much is this rocket going to, how much fuel is this rocket going to use? How much delta V does it have? What kind of burn time am I going to get out of it? Well, what I can do in that kind of circumstance, let's zero out these numbers just so there's no nothing screwy that happens in our spreadsheet. Let's say I've got a rocket with a whole bunch of LVN engines on it. It's got 24 LVN engines on it. By the way, if there's a video of mine where that's exactly the rocket that I've got. And I don't even know what this thing is, full fuel, because I've got probes docked on it, and in KSP that fuel shows also in my total fuel, and I don't want to take the time to do the math and figure out what the max fuel is. I'm not going to worry about it. Let's say I know how much fuel I currently got. I look in MechJeb, and the rocket has, let's say, currently 12,000 units of fuel. So I'm just going to say, well, I'm going to pretend like that's the max fuel the rocket has, is what it currently has. I'm going to put in a matching number for the actual fuel, because that's actually what it has. And now I can just put in the rocket's actual mass. Let's say it weighs, with that amount of fuel, weighs 600 tons. I have no idea what this kind of rocket would weigh. We'll see what kind of number we get. Okay, there we go. That's a pretty heavy rocket for that amount of fuel. But anyway, that's what it weighs. So now what I can see is I don't have to worry about back calculating the mass with full fuel, because I've deceived the spreadsheet to say that the rocket's current fuel is the max fuel. I use the actual mass now for the full fuel. Since I'm using the actual fuel for the full fuel. Now I know what the delta V is of the rocket, 1972. And if I want to come over here and figure out a burn time, let's say I got to do that same 1150. I now know that I've got 7 minutes and 26 seconds of burn time that I'm going to have to use in order to do this maneuver. So you see you can use this spreadsheet even with rockets that don't fit any of the traditional staging parameters, as long as you're not in fact running a stage, or as long as you're willing to manually enter this information for each stage. There you go. Download it. Enjoy it. If you can't figure something out, feel free to send me a message, and I'll be glad to answer. The instructions hopefully are explanatory, and I welcome if anybody makes modifications to the spreadsheet that improves upon it. Please do me a favor and send me a copy so that we can share it around.